This animated video demonstrates the operation of an advanced waste segregation machine designed for clear, safe, and efficient sorting. We will show how different wastes are deposited, automatically identified, and routed into the correct bins step by step. The system separates wet waste, dry waste, hazardous waste, e-waste, medical waste, wood waste, iron materials, and sharp needles. Waste is deposited into the hopper. A feed conveyor moves items into the inspection zone. Here, multiple sensors work together to identify material type and route each item. At the core, a large-scale Arduino-based controller coordinates sensing, decision-making, and actuators in real time. It reads sensor inputs, runs sorting logic, and triggers gates, air jets, and conveyors for precise segregation. Ultrasonic sensors emit high-frequency pulses to measure distance, monitoring current waste levels inside each bin. They also detect item presence, helping time diverters so each piece is guided to the correct chute. A moisture or capacitive sensor distinguishes wet waste by measuring water content and dielectric properties. Low readings indicate dry materials like paper and certain plastics, directing them to the dry waste stream. Infrared optical sensors compare light reflectance and color, aiding identification of paper, plastics, labels, and coatings. A lightweight vision model classifies shapes and markings to refine sorting decisions. The controller then actuates the correct gate at the right moment. Inductive sensors detect ferromagnetic materials like iron through changes in electromagnetic fields. Eddy current sensing distinguishes non-ferrous metals, improving metal separation accuracy. E-waste is recognized by visual cues such as connectors and PCB patterns, corroborated by weight and density checks. Identified electronics are routed to the e-waste bin for specialized recycling. A gas sensor screens for volatile compounds, flagging potentially hazardous items like chemical containers. Optical label detection confirms hazard markings, and the system sends the item to a sealed, hazardous waste bin. Medical waste is identified by the biohazard symbol and item shape profiles such as vials and swabs. A dedicated enclosed chute ensures safe, contamination-limiting transfer to the medical waste bin. Sharp needles are detected by metal sensing combined with shape recognition for elongated, pointed profiles. The machine deposits them into a secure sharps container with an automatic lock for safety. Near-infrared and texture cues help classify wood waste, separating it from plastics and composites. Recovered wood is directed to the wood bin for appropriate reuse or processing. Paper, cardboard, and clean plastics proceed to the dry waste bin for high-quality recycling. Minimal contamination improves material value and downstream efficiency. Food residues and organics are recognized as wet waste and routed to the wet bin. Optional dewatering and compaction reduce volume and manage liquids responsibly. A digital display continuously shows current waste levels for every bin using ultrasonic measurements. When capacity thresholds are reached, alerts are issued for timely, safe removal and logistics. Proper segregation protects workers, reduces contamination, and increases recycling and recovery rates. It also cuts disposal costs and lowers environmental impact over time. You can help by sorting waste correctly at the source. Adopt proper waste segregation practices today and encourage others to do the same.